Hi, welcome to this 30 days Verilog lecture series. So this is day 5. So in day 5, I will explain you the how to write the code for demultiplexer. That is 1 cross 2 demultiplexer, 1 cross 4 demultiplexer, and 1 cross 8 demultiplexer. Okay. So I will execute this one in EDA playground. Next, I will execute in Vivado and Quartus Prime and Model Sim. Okay. So first we'll see the program. So 1 cross 2 Demux. Demux is actually it have one input and many outputs. Okay, two outputs, 1 cross 2 Demux, and one selection line. So this is also called as many one to many circuit, or we can call this as a data distributor. Okay. So here, if you see this code module, and what is my module name? Demux 1:2, and I need to declare input wire D in and input wire selection, and output wire D out and output wire D out 1. Okay, two outputs are there: D out 0 and D out 1. Okay, so I'm using the continuous assignment statement assign. So D out of 0 equal to select. So if select equal to 1, so that means if select equal to 1, so that means 0 is connected to D out of 0, or otherwise selection equal to 0, Dn is connected to D out of 0. Okay. And for D out of 1, if selection equal to 1, Dn is connected to D out of 0, otherwise 0 will be connected. Okay. This is my code end module. Okay. And coming to the test bench, so module. So what is my module name? Test bench Demux 1 cross 2, and I need to declare the variables. Okay, so reg d in and reg select, wire d out and d out of 0 and d out of 1. Okay, so I need to instantiate my design in the test bench. Okay, how to instantiate? Design name. So what is my design name? This both should match. Demux 1 cross 2, and instance name, that is dut, and I need to follow connection by name dot d in, and so whatever the variables outside the bracket are design inputs and outputs, and the variables inside the bracket are test bench variables. Okay, so in order to execute this one in EDA playground, I need to use these two commands. So initial begin. If I am writing multiple statements, I need to write between the initial begin and end. Okay, so $dump file demux underscore 1 cross 2 dot vcd $dump vars 0 comma test bench demux underscore 1 cross 2. So I need to give the stimulus. Okay, so t in equal to 0 and selection equal to 0. Okay, so selection equal to 0 means what? So that 0 is connected to the d out of 0. Okay, d in equal to 1 and selection equal to 0. This 1 is connected to d out of 0. After 10 time minutes, every 10 time minutes, there will be a delay. Okay, and d in is 1 and selection equal to 1. Okay, this 1 is connected to d out of 1. Okay, d in is 0 and selection equal to 1, and this 0 is connected to d out of 1. Okay, dollar finish is actually like to terminate the simulation, dollar finish end, always at the rate these are the input d out of 0 or d out of 1. So I want to display, I'm using the system task dollar display selection equal to, I'm using a format specifier percentage b, d in equal to percentage b, binary. Okay, I want to display in terms of binary. So I'm using d out equal to d out of 0 equal to percentage b, d out of 1 equal to percentage b, select comma d in comma d out of 0, d out of 1. Okay, so this is my code I want to execute in EDA playground. Okay, just to copy this code and go to EDA playground. Okay, so here this is EDA playground, paste here, and coming to the test bench also, copy this code and go to EDA playground. Here we need to paste the test bench. Okay, go to the tools and simulators, Aldec Rivera, and open EP waveform after run. Okay, so save this and run this. So I got this waveform. Okay. Based on this D in only. So when D in equal to 1 and selection equal to 0, D out equal to what? So D out of selection equal to 0, D out of 0 equal to 1. Okay. D in, so here D in is 0 only, no. So D in is 0 means so select D out of 0 equal to 0 only. And D in is 1 and selection equal to what? 1. So whatever the D in value is there, that is coming to D out of 1. Okay. And here if you see, so based on this selection line only, that data will be coming to the output. Okay, you can see in the log file also, when selection equal to 0, D in equal to 0, and so you are getting D out equal to 0 and D out of 1 equal to 0. So whatever the D in value is there, that is coming to, when selection line is equal to 0, it is coming to D out of 0. Okay, when selection equal to 0 and D in is 1. Okay, this data will should come to D out of 0. Okay, see here. When selection equal to 1, this data should come to which one? D out of 1. Okay, D in equal to 1, D out of 1 equal to 1. When selection line equal to 1, so this data should come to D out of 0. So D out of 1, D out of 1, it is come. Okay, so like this we can see in the EDA playground. And coming to Vivado, so go to project, file, new project, next. What is my project name? Let us take project name is Demux, Demultiplexer. I'm giving the project name as Demultiplexer, and choose the location. Location is what? Day 5. Okay. This is my location. Okay, day 5. Next. So I need to create the file now. So I'm giving the module name only. So what is my module name? Demux 1x2. Copy this and create. Okay, paste here. Choose the location. So in that day 5, I created demultiplexer. No? So select this. Okay, next. This is optional only. Next, and finish. Okay, module name is also same. Here, my module is created. Next, go to this code, copy this, and paste here. Save. And go to the simulation, add the simulation source. Okay, create the file name, give the Testbench module name, Testbench Demux _ 1x2. Copy this. So paste here, choose the location, Demux, select, OK, finish, and OK, yes. My Testbench file is created here. Okay, Testbench file is created, and here need to copy this and paste here, save. So if you want to see the circuit RTL analysis, open the elaborated design. Okay. So like this, 2 muxes are there. I implemented like this. So 2 demuxes. So this is data in and 2 outputs. Okay, depending on the selection line, any one of the this data in is connected to any one of this data out. Okay, depending on the selection line. Okay, so like this, the compiler is converted my code into the netlist. Okay, and coming to the waveform, run simulation, run behavioral simulation. So if you see this, so in the TCL console also you will get when selection line equal to 0, D in equal to 0. So whatever the D in value is there, that is coming to D out of 0. And when selection line equal to 0, D in is 1. This 1 value is coming to D out of 0. When selection line equal to 1, D in value, 1 value is coming to D out of 1. And when selection line equal to 1, so D in equal to 0, D out of, so that the D in value is coming to D out of 1 of D out of 1. Okay. So you can see in the waveform also. One second. Just expand this, fit to page. So when selection line equal to 0, okay, D in equal to 0, here that value is coming to D out of 0. Here also, when selection line equal to 0, D in is 1, okay. The value D in is 1 is coming to D out of 0. When selection line is 1, D in equal to 1, that is coming to D out of 0. Sorry, D out of 1. Here D out of 1 is 1. And when selection line is 1, whatever the D in value is there, that is 0, it is coming to D out of 1. Okay. So like this, we can see this 1 cross 2 Demux in the Vivado. Okay. So coming to the Quartus prime. So first you create the project, new project. Okay. So for this, I made 2 files. One is RTL, SIM, and TB. Okay. So this is my RTL file. This is my RTL file, already explained. This RTL file. So whatever this module name is there, give the same name. So copy this and next choose the location. So here yeah, pay file and SIM. Okay, this is my folder and give the project name as that module name only. Demux underscore 1 cross 2. Next, and you need to add the RTL file. So you need to add the RTL file. So the fifth day 5. This is my RTL file. Demux 1 cross 2. Okay. Next, select any FPGA family. Next, and finish. And go to analysis and synthesis. So my RTL code is added in here. Okay, instance it is added. Okay, next right click, start. So I got 0 errors and 1 warning. Next, so warning means nothing will happen. Just so go to netlist viewer and open. So like this, it is converting my code into the gate level netlist. Okay, in terms of like this is a so 1 cross 2 Demux. Okay, 1 cross 2 Demux, and depending on the selection line, you have 2 outputs, D out of 0 and D out of 1. Okay, so this is Quartus prime. And coming to the model sim, I'll open the model sim. So first go to new project. Okay, I will close this. What is my project name? Give the module name only. So what is my module name? So here Demux, or you can give the project name as a Demultiplexer. Okay, so yeah, here you give me, copy this, and project name is Demux, and choose the location. So here day 5 sim. Okay, okay, and add the existing files. So I created a RTL and TB, no. So Demux 1 cross 2, okay. RTL file, and next I need to add the Testbench file. Testbench Demux 1 cross 2, okay. and close. And here what I need to do, right click, compile selected. So I'll get the tick mark so that both are compiled with without any error. Go to library, work, and I need to simulate the test bench. No, so test bench, right click, simulate. So now it is simulated. Go to test bench, add wave. DUT also add wave. Okay, and these are the test bench files. Okay, so just group this test bench TB files. Okay, and so test bench, right click, group, and these are the TB files. Okay, and these are the DUT files. Okay, so group, this is what DUT, and go to run all. No, so my waveform, I got this. Just zoom fit. Okay, I will get this. So see here, when so Demux, when selection equal to 0, D in equal to 0, D out of 1. Okay, D out of 1 equal to 0 only. Okay, so D out of 0 equal to 0 only. When selection equal to 0 and D in is 1, I am getting D out of 1 equal to what? 1. Okay, when selection equal to when D in is 1, selection equal to here. When D in is 1, selection equal to 1. That D in is coming to D out of 1. Okay, D out of 1. And when D in is 0, selection equal to 1, D out of 1 you are getting. So D out of 1 equal to 0 I am getting. Okay. So like this I can see in the in this waveform. Okay. So you can come out from this quit -sim. In transcript window also you got, see here. When select equal to 0, D in equal to 0. So this selection, this D in value I am getting into D out of 0. Okay. When selection equal to 0, D in value is coming to D out of 0. D in is 1, D out of 0 equal to 1. When selection equal to 1, so D in value is coming to D out of 1. Okay. So see here, D out of 1 equal to 1. Okay. And when selection equal to 1, this 0, D in is 0, that is coming to D out of 1. Okay. So if you press quit sim, it will come out from the simulation. Okay. So you can see the program here also. Okay. So this is my program test bench. Okay. Here this is my test bench. You can see here. Okay. So like this we can simulate in the model sim. Okay. Next program. 1x4 Demux. Okay. So 1x4 Demux, if you see. So this is the code for 1x4 Demux. You have module Demux 1x4. This is my module name. And input wire D in and output wire I am using a vector. Okay, 2 selection lines are there now. So that's why 1 down to 0 selection. And 4 outputs will be there. D out of 0, D out of 1, D out of 2, D out of 3. Okay. And I'm using a continuous assignment statement. Assign D out of 0 equal to what? When a selection equal to 2 tick binary 0, 0. So D in will be connected to D out of 0. Otherwise, it is 1 tick binary 0. Okay. Conditional operator or ternary operator. I mean. Okay. D out of 1, that is equal to selection of 0, selection equal to 2 tick binary 0, 1. So D in will be assigned to D out of 1. Otherwise, if condition is not satisfying, it will be 0 only. Assign D out of 2, that is what? Selection equal to 2 tick binary 1, 0. So D in equal to 1 tick binary 0. Okay, so that means D in is assigned to D out of 2, otherwise it is 0. Okay, if D out of 3, that is equal to selection equal to 1, 1, then D in is connected to D out of 3, otherwise it is 0. Okay, so based on this, I wrote the code. You can write with behavioral modeling also. So here I am using the data flow modeling. Okay, this is actually data flow modeling. So test bench, module test bench, Demux 1x4. So I need to declare the internal variables of the test bench. So I am declaring D in with reg data type and selection also 2-bit 1 down to 0 with reg data type, and d out. So wire, so the d out of 0, d out of 1, d out of 2, d out of 3, and declaring with y data type. Okay. Next, I need to instantiate my design. How to instantiate? So this design name should match. Okay. So what is my design name? Demux underscore 1 cross 4, and instance name UUT, and this is connection by name. Okay. So whatever the variables outside the bracket are design inputs and outputs. Whatever the variables inside the bracket are testbench inputs and testbench variables. Okay. So initial begin. These are the two commands I want to generate the waveform in EDA playground. $dump file demux underscore 1 cross 4 dot vcd $dump was 0 comma testbench demux underscore 1 cross 4. So now I need to give the stimulus. Okay. So din equal to 0, selection equal to 0 0. Okay. This din is connected to data out of 0. Okay. When selection equal to again here 0 0, this 1 is connected to data out of 0. Again you are giving din is 1. 0 1 means what? It is connected to data out of 1. And again you are giving 0, it is connected to data out of 2. Selection is 1 0 now. So din equal to 1, and I am giving selection equal to 1 1 means this is connected to data out of 3. Okay. To terminate the simulation, one can use $finish and always at the rate these outputs I want to display. Okay. So I'm using a system $display for displaying all this end module. Okay. So I want to execute in the EDA playground. So just to go to new, and here this I will close. Yeah, see here. So this one, copy this and go to this design and paste here. RTL code right side and test bench left side. So copy this and here paste here. Okay. Save this file. Okay. So select the tools and simulators Altec Rivera. Open EP waveform after run. Save and run. Yeah, here I can see in this one, when selection equal to 0 0, din equal to 0. So this din equal to 0, all are 0 means I can't find. Here you see selection equal to 0 0, din equal to what? This is 1. Okay, it is coming to d out of 0. Okay, selection equal to 0 1, din equal to 1, and it is coming to what? D out of 1. Okay, when selection equal to 1 0, it is coming to which one? 1 0 means what? This signal is din is 0. So here we can't find, all are 0 only. So normally the selection equal to 1 0 means d out of 2 is connected. Okay, so that's why that signal is coming to d out of 2. Selection equal to 1 1, din equal to 1 means what? This is coming to d out of 3. Okay, d out of 3 is connected to d in. So whatever the d in of 1 is there, that is coming to d out of 3. Okay, like this I can see. And coming to the Vivado, so go to design source, add the design source, create the design source, create the file, give the module name only. What is my module name? This is Demux. Copy and paste. Choose the location, demultiplexer, select, OK, finish, and OK. Yes. So this is my demultiplexer. Go to this, copy this code, paste here, save. So I want to see this design. I need to make set as top module. Okay. So this Demux 1 cross 4 is there, no? So I need to set as top module and go to simulation add the simulation, create the simulation source, create the file, and I need to add the test bench. Copy this and paste here, choose the location, demultiplexer, select OK, finish. OK, yes. Here my test bench 1x4 is added, and next copy this, and here you paste over here. So my design is instantiated in the test bench. Right click, set as top module. I want to see the simulation also, no? So I need to make a set as top module. 1x4 module, okay. Open elaborated design. I want to see the circuit, how the code is converted into gate level netlist. Yeah, like this it is converting. In terms of 2x1 mux only, like this it is converting. So depending on the selection line, this data in is connected to any one of the output. Okay. So like this, the tool is converting my code into like gate level netlist. In terms of mux only, I am getting. Okay. And coming to the simulation, run behavioral simulation. So you can see in the TCL console also. See here. So whatever we see in the EDA playground, that we got 0 0. So D in is connected to D out of 0. Okay. D in is 1. Okay. D out of 0 equal to what? 1. Okay. Selection line equal to 0 0. Selection line equal to 0 1. D in is connected to what? D in is connected to D out of 1. Selection line equal to 1 0 means D in is connected to D out of 2. Selection line equal to 1 1. This 1 is connected to D out of 3. Okay. So you can see in the waveform also. So just go to radix, set as binary. So when selection line equal to 0 0, okay. So this D in is connected to what? D out of 0. Okay. Here anyway the input is 0, output is 0 only. Here input is 1, D out of 0 becomes 1. Again when 0 1, 0 1 means what? This D in is connected to D out of 1. Okay. So D out of 1 becomes 1. Okay. And 1 0, D in is 0. So this D out of 2 is, so you are getting the data to D out of 2. Okay. And when it is 1 1, D in is 1. So that data is coming to D out of 3. Data is coming to D out of 3. Okay. So like this we can see in the Vivado. Okay. So like this we can see the circuit also. And coming to the Quartus prime, just file, new project wizard. Okay. Next. So what is my project? I need to give the module name only. Once again, I close this. I created RTL, TB, and Simno. So here I need to give this one. Okay, copy this and paste over here. Next, yeah, next. I need to add that RTL file. Okay, so RTL Demux 1x4, and next to create any FPGA family. Next, finish. So go to analysis and synthesis, start. Okay, I got this. Next, go to netlist viewer, RTL viewer, open. So same, it's looking like as Vivado only, some more equality like that it's showing. Okay, in the Quartus program. Okay, coming to the model sim. So go to file, project. So I want to close this. So what is my project name? Give this file name only. Okay, copy this and paste over here, choose the location. So sim folder only, that is sim folder only, no? So the day5 sim folder is there, same for, so same. I need to add the existing files. Go to RTL, Demux 1x4, okay. Add the existing file, go to TB, add the Testbench files, okay, and select close. Select these two, right click, compile selected. Next, go to library, and in the work, I need to simulate 1x4. No? So right click, simulate. So simulation will start. So go to here. This is the waveform. Testbench, add wave, DUT, add wave. Okay, just to group this. These are the Testbench files. So Testbench. So here TB. This is my TB, and next DOT. So this you need to group DOT files. So group. This is DOT, and OK, and go to run. Run all. Okay. So my waveform will be generated. Just expand this. So here zoom full. So I got this. Okay. So when selection equal to 0, 0, so this D in is connected to D out of 0 only. Okay. And when selection line equal to 0, 0 and the D in is 1, that is connected to D out of 1. I can see same like whatever we seen in the Vivado, same like that I can see in the model C. Okay. You can see here also. Here also you can get. When selection line in the transcript window also, when selection line equal to 0, 0, D in equal to 0, 0. So D in is 0. That D in is connected to what the D is coming to D out of 0. When selection line equal to 0, 0, D in is 1. That data in is coming to D out of 0. And with 0, 1, when selection line is 0, 1, D in is coming to which one? D out of 1. Okay. When selection line is 1, 0, this D in of 0 is coming to D out of 2. When selection line is 1, 1, D in equal to 1. No, this 1 is coming to D out of 3. Okay. Like this we can see in the model sim. Okay. And last program we'll see. So last program, 1x8 Demux. Okay. So this is 1x8 Demux. So module, what is my module name? Demux 1x8. Input wire D in and out input wire. How many selection lines are there? 3 selection lines are there. Okay, that's why I'm declaring with a vector 2 down to 0. And how many outputs are there? Total 8 outputs are there. That's why I'm declaring with the wire data type D out of 0, 1, 2, 3 up to 7. Okay. So I'm testing. I'm checking for what. So that means I'm using a ternary operator, data flow modeling. So assign D out of 0 equal to selection 3 tick binary 0, 0, 0. So D in is connected to D out of 0. Otherwise 0. Okay. 0, 0, 1. D in is connected to D out of 1. If it is 0, 1, 0, D in is connected to D out of 2. Like this. Okay. If it is 1, 1, 1, D in is connected to D out of 7. Okay. This is my RTL code. Okay. Coming to the test bench module. What is my test bench? This is my module name. I need to declare the input, the variables of the test bench. Reg D in. This is multiple bit. I need to declare separately. Reg D down to 0 select. Wire do out to D out of 0, D out of 1 like this. Okay. And next, I need to instantiate my design. Okay. How to instantiate? So design name. These both should match. Design name followed by the instance name and connection by name. Okay. And these are the two files I need to get the waveform. And I'm giving the stimulus. Okay. So D in equal to 0, selection equal to 0, 0, 0. So this value will be assigned to data out of 0. Okay. Again, if it is 1, this 1 is assigned to data out of 0 only. If din is 1, selection equal to 0, 0, 1, this 1 is assigned to d out of 1. Okay. If din is 0, this data in is assigned to d out of 2. Okay. din is 1, this data is assigned to d out of 7. Okay. Like that, I am giving the stimulus. Okay. I am giving the test vectors. And I want to display always at the rate this one. I want to display this one. Okay. So I want to execute in EDA playground. Just go to new and here 1x8. No. So in the GVim, I is for editor mode and escape is for command mode. Okay. I'm pressing I. So editor mode. I'm copying this and go to EDA playground. Here I need to enter the RTL code and coming to the test bench. Here I need to copy and paste here. Okay. And save this file. Okay. I need to select the simulator Aldec Rivera and open EP waveform run. Okay. Without saving also we can run. Yeah. So here you can see in the log file. Okay. So 0, 0, 0. din is 0. This 0 is coming to what d out of 0. Okay. See here, when selection line equal to 0, 0, 0, din is 1. This 1 is coming to what d out of 1. Okay. When selection line is 0, 0, 1, din is 1. This is 1 is coming to din is connected to d out of 1. Okay. D out of 1 is 1. Okay. Here selection line equal to 0, 1, 0. din is 0. This is coming to d out of 2. Okay. Selection line equal to 1, 1, 1. This is coming to d out of 7. Okay. And coming to Vivado. So close this and go to the design source, add the design source, create the design source. Okay. So give the module name, copy this and paste. Use the location demultiplexer, select OK, finish. And module name is also same. So my 1x8 Demux is created. So go to this. So copy this and paste here the Vivado. Save. And so you want to see the design, set as top module in the design source. Okay. Go to the simulation source, add the simulation source, create the simulation source, and give the Testbench file name. So copy this and paste over here. Choose the location where you want to store. Save this file. Finish. Okay. Yes. So my Testbench file is created. Just here, copy this and paste here and save. So right click, set as top module. So open elaborated design. I want to see the design, how the tool is converted my code into gate level netlist in terms of gates. Okay. Like this it is converting. Okay. Then zoom this like this. Demux. Okay. And run the simulation, run behavioral simulation. So you can see the output in TCL console also. See here. And selection line equal to 0, 0, 0, din equal to 0, 1. That is coming to which one? D out of 0. Okay, din is 0, D out of 0 is 0. din is 1, D out of 0 is 1. Okay. And when selection line equal to 0, 0, 1, din is 1. That is coming to D out of 1. Okay. Selection line is 0, 1, 0. That is coming to D out of 2. Selection line is 1, 1, 1. din is 1. That is coming to D out of 7. Okay, randomly I'm checking the inputs. I'm giving the inputs randomly and I'm checking the output. Okay, you can see in the simulation also fit to page. This one you can do binary. Okay, so if it is 0 0 0, d in is 0, that is coming to what, d out of 0. Okay, in these two situations, d in is 0, that is coming to d out of 0. D in is 1, the input is coming to the d out of 0. Okay, so when 0 0 1, here it is coming to which signal, d out of 1. D out of 1 becomes 1, and remaining all are 0 only. Okay, at a time the data input is connected to any one of the output. Okay, and here 0 0 1 0, this 0 is coming to d out of 2. Okay, 1 1 1, 1 1 1 means it is coming to d out of 7. Okay, like this we can analyze the simulation part. Okay, and coming to the Quartus prime, we'll open this. So file, yeah, we'll close, yeah, file, new, second, new project with that. Okay, yes, next, and the path is same only. So choose the project name. What is my project name? Here I wrote RTL, TB, and this one. No, so give the module name only. Make sure that module name is same as the project name in Quartus Prime. And also copy this Quartus Prime. So next, and attach the RTL file. So this is the RTL file. Open, and next, so choose the FPGA family. Next, finish. Go to analysis and synthesis. Start. So yeah, 0 errors and 1 warning I got. Yeah, so go to analysis and next go to netlist viewer, RTL viewer, open. So like this I am getting the circuit in terms of in the Quartus prime. Okay, coming to the model sim, so just here quit sim, quit hyphen sim, it will come out from the simulation. Go to file, new project. Okay, new project. So I want to close this project. So what is my project name? Just give the same thing only, Demux, and the path is same only. Okay, and add the existing file, add the RTL file, TB file. So Demux 1x8. Okay, again add the TB file, 1x8. Open. Okay, close. Select compile selected. I got tick mark. Go to library, and this test bench is there. No, right click, simulate. Simulation started. Okay, so run all. So run all. No. Again, I got this waveform. See here, this waveform. Go to this test bench, add wave. Go to DUT, add wave. Okay, so these yeah. So this one I need to group. Right click, group, and this is TB files, and these are the DUT files. Right click and group. These are the DUT files. Okay, and so run all. I got this. Just expand. Just expand. and here you can see zoom full. Okay, I can get this waveforms. So, you see in the transcript window also I got this. See here. So selection line equal to 0, 0, 0, D in equal to 0. So D out is 0. So D here you see. So D in is 1. So this D out, D in is connected to D out of 0. Okay. So D out of 0 is 1. Okay. 0, 0, 1, D in is 1. D out of 1 equal to 1. Okay. 0, 1, 0, D in of 0 equal. So D in equal to 0, you are getting at D out of 2. Okay. 1, 1, 1 means you are getting the output at D out of 7. Okay. Like this I can see in the transcript window also. Okay. If you want to come out from the simulation, quit sim. Okay. The command is quit -sim. Will come out from the. Okay. So like this we can see the simulation and whatever the synthesis gate level netlist for 1x2 Demux, 1x4 Demux, and 1x8 Demux in EDA Playground, Xilinx Vivado, and Quartus Prime, and models. Okay. Okay. Thank you.